Greetings. Welcome to Mat140. We're going to discuss section 8.2, which involves interest. And there's two types of interest. We're going to talk about simple interest and then compound interest. So what is interest? Interest is principal times rate times time, and time is usually in terms of years. Okay. So we abbreviate this formula as I equals P. Well, first of all, you're figuring what the heck are you talking about? Principal. Principal is the amount of money that you invest or you put into something or that you owe. That's the principal amount. Times rate. Rate would be as a percent. And then time, we said, is usually a quantity in terms of years. So it's PRT. Maybe we can even shorten it down to this. When you see three letters like this and there's no symbol in between, that means times. Okay, so we're going to multiply those together. So let's try one here. You're going to put $500. Oh, let's see. Make sure I get the right one. So that's what interest is. Okay, let's look at this one, example one. It says you deposit $500 in a bank account at 6% interest. At the end of 4 years, how much money will you have? When it says that you deposit computes the interest using simple interest. Okay. So you're putting $500. That would be the principal amount. The rate is 6%, but when we're using a formula again, we can't just, when we put into a formula, percent has to be always changed to a decimal. So we're going to change this to a decimal, 0.06. And another way we can show times is by putting parentheses. And time, the time involved in this is going to be 4 years. So if we multiply these three quantities together, 500 times 6%, 0.06 times 4 years, we get $120. And that's the interest. Either you're going to, it depends what you're doing. If you're receiving this money, then you would get $500 back plus your interest. If you're paying it out, then you get 500 minus your interest. So the interest after 4 years is 120. Okay, so let's try another one of those. Let's see if we can do it. We're going to try to find the future value. What the heck are they talking about? The future value is the amount in the account in the future using simple interest. But we're going to do a little variation on this because we're going to do it for a period of time. We could do it this way, but this is another variation on that formula. And this would give you the amount in the account after 6 years, and we can do it all at one time. This way, it just calculated out the interest. Then we had to take the interest, which was 120, and add it to the principal, which was 500. And then we could find the amount in the account after, what was this, 4 years, you'd have $620. So we had to do it in 2 steps. We had to figure out the interest, which was money, and then we had to do the amount. This formula allows you to do it in just 1 step. So let's see if we can find the amount. And what it's doing right here is it's adding it at the same time, multiplying and all that good stuff. So the principal that you're putting in is $1,000. And you're putting in this account, and one is just part of the formula. One is the part of the formula. Plus the rate of interest, again, rate 3%, but we aren't going to use 3%. We're going to use 0.03. 3%, you move it 2 places, add that decimal, and then move it 2 places. You don't want to make it 30. It's 0.03. You want to move your decimal point 2 places over, 0.03. And then times the time, put a little time sign there, times the time, which was 6 years. So I'm going to break this down in step by step, and then I'll show you a quicker way. 1 plus 0.03 times 6. And that came out to be 0.18. Now, 1 plus 0.18 is just simply 1.18. It's pretty easy to add a whole number. You just put the whole number in front, huh? And then finally you're going to multiply that out. So 1.18 times 1,000 equals. So the amount that you have coming back to you after 6 years is $1,180. That will be the amount that you have back, coming back to you. Doesn't seem like a huge amount, but at 3%, it's not a real huge amount of interest. Okay? So that's what we call the future value, But some people put their money into an account that's compounded. Banks usually compound your interest. Car loans are compounded now. So to compound, what we do is we put the money into the bank, and after every year, it adds the amount back to it. I'll give you an example in the book. If we were to put, say our rate of interest is, let's say on this particular loan, it's 10%. So we have $2,000 at 10%. And we want to find out how much we're going to have in 3 years. So if we put $2,000 into the bank, we multiply 0.10 times 2,000, that would give us $200. So at the end of the year, we would have $2,200 coming back to us, simple interest. But this is where it differs from simple interest. Simple interest would start with 2,000 again the next year and the next year, and then would add them all up. So that would be around whatever, I don't know exactly how much you would have. But what we're going to do is we're going to start out with the $2,200, and we're going to figure 10% on that, and that's 2,420. That's how much you have coming back after the second year. If you did it with simple interest, you put 2,000 in, you'd have 2,200. The next year, you'd have another 200 coming back to you, so you'd have 2,400. So you gain $20. And then the next year on compound interest, you start out at 2,420, and you put your money into the bank, and you would have $2,662. With simple interest, you'd have $2,600. So you made a little extra money. For a short period of time, you're not going to make a lot of money. But over a period of time, 30 years, this is going to start to really accumulate, and you're going to make a lot more money. So each year, the starting amount changes. On simple interest, it always stays 2,000 every year. And then we add the interest on, and we get that. So obviously, you don't want to do this each time. If you had 30 years, you don't want to write that down 30 times. So what we're going to do is find out the future value of this same thing, $1,000 at 3% for 6 years using compound interest. Remember, on simple interest, let's write it down here at the bottom. Simple interest this money grew from $1,000. And at the end of 6 years, you had $1,180 coming back to you. Here you go, I'm sorry. Simple interest. This was at 3%. This is your amount after. Now let's see what it would be with this one. We're going to put it into this formula. A equals 1,000. Now notice my formula is a little different. 1 plus, what is R? R is the rate of interest, and again, it can't be a percent. So this has to be 0.03. Okay? Then we're going to divide it by the number of times your account is compounded. And it's compounded monthly. So we're going to divide that by 12. Could be, if they say quarterly, that means 4 times, 4 quarters in a tower. Every 3 months, you put 3. That would be quarterly. Semi-annually would be 2. Annual would be 1. So we put this number down. Now we're going to take that same number we wrote down here and then multiply it by the number of years, 6. That's why you need a kind of a fancy-dancy calculator. So this is going to change this to, let's do it right here. That's going to become 72. It's easier, don't put the 12 times 6, actually just multiply it out. I mean, you could write it down, but then put a 72 above it. Okay? So let's put it into and we're going to use our calculator for this. I'm going to show you how to put this on your calculator in one step. So let's clear this all out. We're going to put 1,000. We're going to put the parentheses just like it had in the problem. We're going to put the 1 plus 0.03 divide by 12. I'm going to put a parentheses to end it, just like we have. And then to raise it to the 72, we're going to use this up arrow key right here. We're going to hit our up arrow. This will raise it to 72. So it's going to calculate all this together. Boom. Should get it right. At the end of this period of time, you have $1,196.95 coming to you. So you gained about $16, $17 by doing it by compound. But this is a short period of time. So normally we are going to use this for a long time. Okay. So that's the difference between simple interest and compound interest. Simple interest, compound interest. All right. Let's look at another example here. You've probably seen these ads in the paper where it says no down payment, no payment for 6 months. And you're trying to figure out how much interest are you going to pay. So this will be compounded. We're going to use that compound formula. Save a little bit of time. We're going to substitute our money amounts in here. $3,500 is how much you're borrowing. 1 plus 0.12, and we're making monthly payments, but no payments for 6 months. But if we were making payments, this would be 12. And this is the interest rate. They said this was at 12%. Most of the time, these loans are closer to 18% or 24%, sometimes 30%. They're very high interest rates. This has to be in terms of years, time. So we're going to use the 6 divided by 12, because that's 6 months out of 12 months. And then we're going to multiply it by this number that was on the bottom. Remember, we put that on the top. So because we don't have a year, yeah, I guess you could write down half a year. You could put a half here times the 12. So that's going to come out to a 6. And 0.12 divided by 12 is 0.01. And I'm going to put that in my calculator. Let's do it right now. Parentheses, 1 plus 0.01, parentheses, raised to the, 12th. 6 is 3715 point. Well, I came up with 3.2. The book came up with 3.3. So, maybe just slightly different. So if we wanted to find out how much interest you would pay over that period of time, we're going to take the 3,500 and subtract it from this new amount. And this is how much interest you would pay. Even though you don't have to make no payment for 6 months, they're going to charge you this interest for 6 months. They're going to add that onto your bill. So when you go to pay it back, you didn't have to make a payment, but now you have to pay back this extra interest. They're still charging the interest during that period of time. It's kind of tricky because it sounds like you don't have to pay anything for 6 months, but you do. You still have to pay this interest. They're not deferring the interest. They're just deferring the payment. So you have to be kind of careful about that. The interest is still going to go on. Not a huge amount, but it's still money out of your pocket. So, keep that in mind when they say on a car payment or something like that, you buy this car, no down, no payments for 6 months. Yes, you don't have to make a payment, but you do have to pay the interest. And so you got to be careful about that. Okay, finding the present value. Maybe you had a child and you wanted to save up for that child, and here's our basic formula. And you wanted to save up for this child, and you wanted to see how much it would take you, how much money you'd have to start out with to raise $60,000. Okay, so that's the amount you want at the end. And you're trying to figure out how much money I would have to put in. Sometimes this is called a sinking fund. Sinking fund. That's what we're kind of doing. We're figuring out, I don't know how they came up with this name, but we're trying to figure out how much you would have to sink into this investment to get $60,000 at the end. So that's why they call it a sinking fund. You're going to put some money in to get this amount at the end. And we want to know how much you'd have to put in. Well, you'd have to know a couple of things. Number one, what's the interest rate? They're going to give you a 4.8%. How much is it done? It's done quarterly. And I ran out of room. It's supposed to say quarterly. And what else would you have to know? How many years you want this pay off at age 18? So you're going to put it in for 18 years. You're going to save up this money over a period of 18 years. You figure when your kid turns 18, they're going to go off to college. They're going to need about $60,000 to pay off there, and then they won't have to take out maybe loans. It depends what they're going to major in. And if they went to Hewitt Community College through Eastern Arizona, I should say Hewitt Community Campus, it would be a lot less than 60,000. Okay, but that would only be for 2 years. 1 plus rate of interest. What are we going to do with that interest? Move it 2 places, 0.048. Quarterly, 4 times a year. What are we going to do with that quarterly? Put it up here times the number of years times 18. Definitely need a big calculator for that. Let's see what 4 times 18 is. 4 times 18. Let me see if I turn this slide on, if it would help. Yeah, it does a little bit. 4 times 18. Bingo, 72. So we don't want to use this number. Let's put a 72 up there. Let's put the cap back on the pen. All right, got it. So now we got this all written down. Very nice, huh? Which we can't really put this into our calculator very well. We could do this part. 1 plus 0.048 divided by 4. We can do that. 1.012. And that's going to be raised to the 72nd power. So I did this parentheses. And then I'm going to raise that to the power. And see, it's still on my calculator. You can see it. Raised to the 72nd power. See, hit that little up arrow. 2.316. So let's write that down. And of course, the more numbers you write down, the more accurate this is going to be. We're just going to use 2.36. But if you went all the way out, it'd probably be a little bit more accurate. Now, what are we going to do to find P? P, and P is the variable. This is our number. To get it by itself, we're going to divide both sides by the number with P. So P, this is how much you're going to have to start out with. This is how much you're going to have to sink into that fund to get 60,000 at the end. Divide by, say, divide 2.36. $25,423.73. It's called $25,424. You got to start out with. You have that in your bank account? Now, the book came out with a slightly different answer. Again, that might be because they carried this out substantially further than what I did. So, but roughly about $25,400 is what you're going to have to start out with to get that kind of money back. Okay, the last problem we want to do is something called doubling time. It says Dee Dee has invested $8,500 in the old Star Wars memorabilia. She's invested all this money, $8,400. Hopefully it will go up. It's currently increasing at 6.5% per year. If the increase continues at the same rate, how many years will it take? And they did it this way. And if you notice when they got through, they did a lot of calculation here using that formula we've been using. And then when they got through with that, and they had to go into something called logarithms and calculate it all out. That's pretty hard to find a doubling time. Show you a shortcut. Shortcut to the doubling time, 70 divided by the percent. You always use 70, and you always divide it by the 70 by the percent, and it will always show you the doubling time. If you want this $8,500, which is your initial investment, you want to know how long it's going to take you for this to double. How many years? This is going to give you the years. 70 divided by, and what's nice about this is you don't have to change the percent to a decimal. You just use 6.5%. And you're going to take 70 and you're going to divide it by 6.5. They don't show you this in the book. Bingo. About 10.7 years, or roughly 11 years, maybe a little less than 11 years, your investment, you should have $1,700 now. This stuff should be worth if it continues. Now, if you take a look at the way the book did it, what did they come up with? 11 years. In fact, this is probably a little bit, well, I don't know if it's more accurate, but it's pretty close. Another way you can do it, on your calculator, you have an ln key. You're going to put ln and always 2, ln2, divided by, now you would change this to a decimal, 0.065. Change that 6.5% to a decimal and use ln2. When I hit ln2, see what happens? It comes out to about 0.70. Okay. So I'm going to hit ln2, but I need to finish the parentheses, divided by 0.065, 10.66. And this is actually more accurate than what the book has. But again, rounding it off, it's about 11 years. This is probably a little bit easier. This is called the rule of 70. Not in your book, but a fast way to do a doubling time. Doubling time, 70 divided by the percent. Or you can get a little fancier, ln2 divided by, then you have to change that to a decimal. But both of them, there isn't a huge amount of difference between the two. And you can figure out how something doubles. So if you use that little doubling rule, it's going to be a lot easier. Okay. Hopefully this video will help you when you start to do these problems.